CHAPTER VIII of Great Astronomers by Sir Robert S. Ball. This recording is in the public domain. CHAPTER VIII Halley. Isaac Newton was just 14 years of age when the birth of Edmund Halley, who was destined in after years to become Newton's warmly attached friend and one of his most illustrious scientific contemporaries, took place. There can be little doubt that the fame as an astronomer which Halley ultimately acquired, great as it certainly was, would have been even greater still had it not been somewhat impaired by the misfortune that he had to shine in the same sky as that which was illumined by the unparalleled genius of Newton. Edmund Halley was born at Haggerston, in the parish of St. Leonard's, Shoreditch, on October 29th, 1656. His father, who bore the same name as his famous son, was a soap boiler in Winchester Street, London, and he had conducted his business with such success that he accumulated an ample fortune. I have been unable to obtain more than a very few particulars with respect to the early life of the future astronomer. It would, however, appear that from boyhood he showed considerable aptitude for the acquisition of various kinds of learning, and he also had some capacity for mechanical invention. Halley seems to have received a sound education at St. Paul's School, under the care of Dr. Thomas Gale. Here the young philosopher rapidly distanced his competitors in the various branches of ordinary school instruction. His superiority was, however, most conspicuous in mathematical studies, and, as a natural development of such tastes, we learn that by the time he had left school he had already made good progress in astronomy. At the age of 17 he was entered as a commoner at Queen's College, Oxford, and the reputation that he brought with him to the university may be inferred from the remark of the writer of Athenae Oxonienses, that Halley came to Oxford with skill in Latin, Greek, and Hebrew, and such a knowledge of geometry as to make a complete dial. Though his studies were thus of a somewhat multifarious nature, yet it is plain that from the first his most favourite pursuit was astronomy. His earliest efforts in practical observation were connected with an eclipse which he observed from his father's house in Winchester Street. It also appears that he had studied theoretical branches of astronomy so far as to be conversant with the application of mathematics to somewhat abstruse problems. Up to the time of Kepler, philosophers had assumed almost as an axiom that the heavenly bodies must revolve in circles, and that the motion of the planet around the orbit which it described must be uniform. We have already seen how that great philosopher, after very persevering labour, succeeded in proving that the orbits of the planets were not circles, but that they were ellipses of small eccentricity. Kepler was, however, unable to shake himself free from the prevailing notion that the angular motion of the planets ought to be of a uniform character around some point. He had indeed proved that the motion round the focus of the ellipse in which the sun lies is not of this description. One of his most important discoveries even related to the fact that at some parts of its orbit a planet swings around the sun with greater angular velocity than at others. But it so happens that in elliptic tracks which differ but little from circles, as is the case with all the more important planetary orbits, the motion round the empty focus of the ellipse is very nearly uniform. It seemed natural to assume that this was exactly the case, in which event each of the two foci of the ellipse would have had a special significance in relation to the movement of the planet. The youthful Halley, however, demonstrated that so far as the empty focus was concerned, the movement of the planet around it, though so nearly uniform, was still not exactly so, and at the age of 19 he published a treatise on the subject, which at once placed him in the foremost rank amongst theoretical astronomers. But Halley had no intention of being merely an astronomer with his pen. He longed to engage in the practical work of observing. He saw that the progress of exact astronomy must depend largely on the determination of the positions of the stars with all attainable accuracy. He accordingly determined to take up this branch of work, which had been so successfully initiated by Tycho Brahe. At the present day, astronomers of the great national observatories are assiduously engaged in the determination of the places of the stars. A knowledge of the exact positions of these bodies is indeed of the most fundamental importance, not alone for the purposes of scientific astronomy, but also for navigation, and for extensive operations of surveying in which accuracy is desired. The fact that Halley determined to concentrate himself on this work shows clearly the scientific acumen of the young astronomer. Halley, however, found that Hevelius at Dantzig and Flamsteed, the Astronomer Royal at Greenwich, were both engaged on work of this character. He accordingly determined to direct his energies in a way that he thought would be more useful to science. He resigned to the two astronomers whom I have named the investigation of the stars in the northern hemisphere, and he sought for himself a field hitherto almost entirely unworked. He determined to go to the southern hemisphere, there to measure and survey those stars which were invisible in Europe, so that his work should supplement the labours of the northern astronomers, and that the joint result of his labours and of theirs might be a complete survey of the most important stars on the surface of the heavens. In these days, after so many ardent students everywhere have devoted themselves to the study of nature, it seems difficult for a beginner to find a virgin territory in which to commence his explorations. Halley may, however, be said to have enjoyed the privilege of commencing to work in a magnificent region, the contents of which were previously almost entirely unknown. Indeed, none of the stars which were so situated as to have been invisible from Tycho Brahe's observatory at Uraniborg in Denmark, could be said to have been properly observed. There was, no doubt, a rumour that a Dutchman had observed southern stars from the island of Sumatra, and certain stars were indicated in the southern heavens on a celestial globe. On examination, however, Halley found that no reliance could be placed on the results which had been obtained, so that practically the field before him may be said to have been unworked. At the age of 20, without having even waited to take that degree at the university which the authorities would have been glad to confer on so promising an undergraduate, this ardent student of nature sought his father's permission to go to the southern hemisphere for the purpose of studying the stars which lie around the southern pole. His father possessed the necessary means, and he had likewise the sagacity to encourage the young astronomer. He was indeed most anxious to make everything as easy as possible for so hopeful a son. He provided him with an allowance of £300 a year, which was regarded as a very munificent provision in those days. Halley was also furnished with letters of recommendation from King Charles II, as well as from the directors of the East India Company. He accordingly set sail with his instruments in the year 1676, in one of the East India Company's ships, for the island of St. Helena, which he had selected as the scene of his labours. After an uneventful voyage of 3 months, the astronomer landed on St. Helena, with his sextant of 5½ feet radius, and a telescope 24 feet long, and forthwith plunged with ardour into his investigation of the southern skies. He met, however, with one very considerable disappointment. The climate of this island had been represented to him as most favourable for astronomical observation, but instead of the pure blue skies which he had been led to expect, he found that they were almost always more or less clouded, and that rain was frequent, so that his observations were very much interrupted. On this account he only remained at St. Helena for a single year, having, during that time, and in spite of many difficulties, accomplished a piece of work which earned for him the title of "Our Southern Tycho." Thus did Halley establish his fame as an astronomer on the same lonely rock in mid-Atlantic, which nearly a century and a half later became the scene of Napoleon's imprisonment, when his star, in which he believed so firmly, had irretrievably set. On his return to England, Halley prepared a map which showed the result of his labours, and he presented it to the king in 1677. Like his great predecessor, Tycho, Halley did not altogether disdain the arts of the courtier, for he endeavoured to squeeze a new constellation into the group around the southern pole which he styled the Royal Oak, adding a description to the effect that the incidents of which the Royal Oak was a symbol were of sufficient importance to be inscribed on the surface of the heavens. There is reason to think that Charles II duly appreciated the scientific renown which one of his subjects had achieved, and it was probably through the influence of the king that Halley was made a Master of Arts at Oxford on November 18, 1678. Special reference was made on the occasion to his observations at St. Helena, as evidence of unusual attainments in mathematics and astronomy. This degree was no small honour to such a young man, who, as we have seen, quitted his university before he had the opportunity of graduating in the ordinary manner. On November 30th, in the same year, the astronomer received a further distinction in being elected a Fellow of the Royal Society. From this time forward he took a most active part in the affairs of the Society, and the numerous papers which he read before it form a very valuable part of that notable series of volumes known as the Philosophical Transactions. He was subsequently elected to the important office of Secretary to the Royal Society, and he discharged the duties of his post until his appointment to Greenwich necessitated his resignation. Within a year of Halley's election as a Fellow of the Royal Society, he was chosen by the Society to represent them in a discussion which had arisen with Hevelius. The nature of this discussion, or rather the fact that any discussion should have been necessary, may seem strange to modern astronomers, for the point is one on which it would now seem impossible for there to be any difference of opinion. We must, however, remember that the days of Halley were, comparatively speaking, the days of infancy as regards the art of astronomical observation, and issues that now seem obvious were often, in those early days, the occasions of grave and anxious consideration. The particular question on which Halley had to represent the Royal Society may be simply stated. When Tycho Brahe made his memorable investigations into the places of the stars, he had no telescopes to help him. The famous instruments at Uraniborg were merely provided with sights, by which the telescope was pointed to a star on the same principle as a rifle is sighted for a target. Shortly after Tycho's time, Galileo invented the telescope. Of course everyone admitted at once the extraordinary advantages which the telescope had to offer, so far as the mere question of the visibility of objects was concerned. But the bearing of Galileo's invention upon what we may describe as the measuring part of astronomy was not so immediately obvious. If a star be visible to the unaided eye, we can determine its place by such instruments as those which Tycho used, in which no telescope is employed. We can, however, also avail ourselves of an instrument in which we view the star not directly, but through the intervention of the telescope. Can the place of the star be determined more accurately by the latter method than it can when the telescope is dispensed with? With our present knowledge, of course, there is no doubt about the answer. Everyone conversant with instruments knows that we can determine the place of a star far more accurately with the telescope than is possible by any mere sighting apparatus. In fact, an observer would be as likely to make an error of a minute with the sighting apparatus in Tycho's instrument as he would be to make an error of a second with the modern telescope, or, to express the matter somewhat differently, we may say, speaking quite generally, that the telescopic method of determining the places of the stars does not lead to errors more than 1/60th part as great as which are unavoidable when we make use of Tycho's method. But though this is so apparent to the modern astronomy, it was not at all apparent in the days of Halley, and accordingly he was sent off to discuss the question with the continental astronomers. Hevelius, as the representative of the older method, which Tycho had employed with such success, maintained that an instrument could be pointed more accurately at a star by the use of sights than by the use of a telescope, and vigorously disputed the claims put forth by those who believed that the latter method was the more suitable. On May 14th, 1679, Halley started for Dantzig, and the energetic character of the man may be judged from the fact that on the very night of his arrival he commenced to make necessary observations. In those days astronomical telescopes had only obtained a fractional part of the perfection possessed by the instruments in our modern observatories, and therefore it may not be surprising that the results of the trial were not immediately conclusive. Halley appears to have devoted much time to the investigation; indeed, he remained at Dantzig for more than a twelvemonth. On his return to England, he spoke highly of the skill which Hevelius exhibited in the use of his antiquated methods, but Halley was nevertheless too sagacious an observer to be shaken in his preference for the telescopic method of observation. The next year we find our young astronomer starting for a continental tour, and we, who complain if the Channel passage lasts for more than an hour or two, may note Halley's remark in writing to Hooke on June 15th, 1680. Having fallen in with bad weather, we took 40 hours on the journey from Dover to Calais. The scientific distinction which he had already attained was such that he was received in Paris with marked attention. A great deal of his time seems to have been passed in the Paris Observatory, where Cassini, the presiding genius, himself an astronomer of well deserved repute, had extended a hearty welcome to his English visitor. They made observations together of the place of the splendid comet which was then attracting universal attention; and Halley found the work thus done of much use when he subsequently came to investigate the path pursued by this body. Halley was wise enough to spare no pains to derive all possible advantages from his intercourse with the distinguished savants of the French capital. In the further progress of his tour, he visited the principal cities of the continent, leaving behind him everywhere the memory of an amiable disposition and of a rare intelligence. After Halley's return to England, in 1682, he married a young lady named Mary Tooke, with whom he lived happily till her death 55 years later. On his marriage, he took up his abode in Islington, where he erected his instruments and recommenced his observations. It has often been the good fortune of astronomers to render practical services to humanity by their investigations, and Halley's achievements in this respect deserve to be noted. A few years after he had settled in England, he published an important paper on the variation of the magnetic compass, for so the departure of the needle from the true north is termed. This subject had indeed early engaged his attention, and he continued to feel much interest in it up to the end of his life. With respect to his labours in this direction, Sir John Herschel says, "To Halley we owe the first appreciation of the real complexity of the subject of magnetism. It is wonderful indeed, and of a striking proof of the penetration and sagacity of this extraordinary man, that with his means of information he should have been able to draw such conclusions, and to take so large and comprehensive a view of the subject as he appears to have done." In 1692, Halley explained his theory of terrestrial magnetism, and begged captains of ships to take observations of the variations of the compass in all parts of the world, and to communicate them to the Royal Society, in order that all the facts may be readily available to those who are hereafter to complete this difficult and complicated subject. The extent to which Halley was in advance of his contemporaries in the study of terrestrial magnetism may be judged from the fact that the subject was scarcely touched after his time until the year 1811. The interest which he felt in it was not merely of a theoretical kind, nor was it one which could be cultivated in an easy chair. Like all true investigators, he longed to submit his theory to the test of experiment, and for that purpose Halley determined to observe the magnetic variation for himself. He procured from King William III the command of a vessel called the Paramour Pink, with which he started for the South Seas in 1694. This particular enterprise was not, however, successful; for, on crossing the line, some of his men fell sick and one of his lieutenants mutinied, so that he was obliged to return the following year with his mission unaccomplished. The government cashiered the lieutenant, and Halley, having procured a second smaller vessel to accompany the Paramour Pink, started once more in September 1699. He traversed the Atlantic to the 52nd degree of southern latitude, beyond which his further advance was stopped. "In these latitudes," he writes to say, "we fell in with great islands of ice, of so incredible height and magnitude that I scarce dare write my thoughts of it." Upon his return in 1700, Halley published a general chart, showing the variation of the compass at the different places which he had visited. On these charts he set down lines connecting those localities at which the magnetic variation was identical. He thus set an example of the graphic representation of large masses of complex facts, in such a manner as to appeal at once to the eye, a method of which we make many applications in the present day. But probably the greatest service which Halley ever rendered to human knowledge was the share in which he took in bringing Newton's Principia before the world. In fact, as Dr. Glaisher, writing in 1888, has truly remarked, but for Halley the Principia would not have existed. It was a visit from Halley in the year 1684 which seems to have first suggested to Newton the idea of publishing the results of his investigations on gravitation. Halley, and other scientific contemporaries, had no doubt some faint glimmering of the great truth which only Newton's genius was able fully to reveal. Halley had indeed shown how, on the assumptions that the planets move in circular orbits round the sun, and that the squares of their periodic times are proportional to the cubes of their mean distances, it may be proved that the force acting on each planet must vary inversely as the square of its distance from the sun. Since, however, each of the planets actually moves in an ellipse, and therefore at continually varying degrees from the sun, it becomes a much more difficult matter to account mathematically for the body's motions on the supposition that the attractive force varies inversely as the square of the distance. This was the question with which Halley found himself confronted, but which his mathematical abilities were not adequate to solve. It would seem that both Hooke and Sir Christopher Wren were interested in the same problem. In fact, the former claimed to have arrived at a solution, but declined to make known his results, giving as an excuse his desire that others having tried and failed might learn to value his achievements all the more. Halley, however, confessed that his attempts at the solution were unsuccessful, and Wren, in order to encourage the other two philosophers to pursue the inquiry, offered to present a book of 40 shillings value to either of them who should in the space of 2 months bring him a convincing proof of it. Such was the value which Sir Christopher set on the law of gravitation, upon which the whole fabric of modern astronomy may be said to stand. Finding himself unequal to the task, Halley went down to Cambridge to see Newton on the subject, and was delighted to learn that the great mathematician had already completed the investigation. He showed Halley that the motions of all the planets could be completely accounted for on the hypothesis of a force of attraction directed towards the sun, which varies inversely as the square of the distance from that body. Halley had the genius to preserve the tremendous importance of Newton's researches, and he ceased not to urge upon the recluse man of science the necessity for giving his new discoveries publication. He paid another visit to Cambridge with the object of learning more with regard to the mathematical methods which had already conducted Newton to such sublime truths, and he again encouraged the latter both to pursue his investigations and to give some account of them to the world. In December of the same year, Halley had the gratification of announcing to the Royal Society that Newton had promised to send that body a paper containing his researches on gravitation. It seems that at this epoch the finances of the Royal Society were at a very low ebb. This impecuniosity was due to the fact that a book by Willoughby, entitled De Historia Praesium, had been recently printed by the Society at great expense. In fact, the coffers were so low that they had some difficulty in paying the salaries of their permanent officials. It appears that the public did not care about the history of fishes, or at all events the volume did not meet with the ready demand which was expected for it. Indeed, it has been recorded that when Halley had undertaken to measure the length of a degree of the earth's surface at the request of the Royal Society, it was ordered that his expenses be defrayed either in £50 sterling or in 50 books of fishes. Thus it happened that on June 2nd the Council, after due consideration of ways and means in connection with the issue of the Principia, ordered that Halley should undertake the business of looking after the book and printing it at his own charge, which he was engaged to do. It was, as we have elsewhere mentioned, characteristic of Newton that he detested controversies, and he was, in fact, inclined to suppress the third book of the Principia altogether rather than have any conflict with Hooke with respect to the discoveries there enunciated. He also thought of changing the name of the work to De Motu Corporum Libri Duo, but upon second thoughts he retained the original title, remarking, as he wrote to Halley, "It will help the sale of the book, which I ought not to diminish, now it is yours," a sentence which shows conclusively, if further proof were necessary, that Halley had assumed the responsibility of its publication. Halley spared no pains in pushing forward the publication of his illustrious friend's great work, so that in the same year he was in a position to present a complete copy to King James II, with a proper discourse of his own. Halley also wrote a set of Latin hexameters in praise of Newton's genius, which he printed at the beginning of the work. The last line of this specimen of Halley's poetic muse may be thus rendered: "Nor mortals nearer may approach the gods." The intimate friendship between the two great astronomers of the time continued without interruption till the death of Newton. It has, indeed, been alleged that some serious cause of estrangement arose between them. There is, however, no satisfactory ground for this statement. Indeed, it may be regarded as effectually disposed of by the fact that, in the year 1727, Halley took up the defence of his friend, and wrote two learned papers in support of Newton's system of chronology, which had been seriously attacked by a certain ecclesiastic. It is quite evident to any one who has studied these papers that Halley's friendship for Newton was as ardent as ever. The generous zeal with which Halley adopted and defended the doctrines of Newton, with regard to the movements of the celestial bodies, was presently rewarded by a brilliant discovery, which has more than any of his other researches rendered his name a familiar one to astronomers. Newton, having explained the movement of the planets, was naturally led to turn his attention to comets. He perceived that their journeyings could be completely accounted for as consequences of the attraction of the sun, and he laid down the principles by which the orbit of a comet could be determined, provided that observations of its positions were obtained at 3 different dates. The importance of these principles was by no one more quickly recognised than by Halley, who saw at once that it provided the means of detecting something like order in the movements of these strange wanderers. The doctrine of gravitation seemed to show that just as the planets revolved around the sun in ellipses, so also must the comets. The orbit, however, in the case of the comet, was so extremely elongated that the very small part of the elliptical path within which the comet is both near enough and bright enough to be seen from the earth, is indistinguishable from a parabola. Applying these principles, Halley thought it would be instructive to study the movements of certain bright comets, concerning which reliable observations could be obtained. At the expense of much labour, he laid down the paths pursued by 24 of these bodies, which had appeared between the years 1337 and 1698. Amongst them he noticed 3 which followed tracks so closely resembling each other that he was led to conclude the so-called 3 comets could only have been 3 different appearances of the same body. The first of these occurred in 1531, the second was seen by Kepler in 1607, and the third by Halley himself in 1682. These dates suggested that the observed phenomena might be due to the successive returns of one and the same comet after intervals of 75 or 76 years. On the further examination of ancient records, Halley found that a comet had been seen in the year 1456, a date, it will be observed, 75 years before 1531. Another had been observed 76 years earlier than 1456, viz., in 1380, and another 75 years before that, in 1305. As Halley thus found that a comet had been recorded on several occasions at intervals of 75 or 76 years, he was led to the conclusion that these several apparitions related to one and the same object, which was an obedient vassal of the sun, performing an eccentric journey round that luminary in a period of 75 or 76 years. To realize the importance of this discovery, it should be remembered that before Halley's time a comet, if not regarded merely as a sign of divine displeasure, or as an omen of intending disaster, had at least been regarded as a chance visitor to the solar system, arriving no one knew whence, and going no one knew whither. A supreme test remained to be applied to Halley's theory. The question arose as to the date at which this comet would be seen again. We must observe that the question was complicated by the fact that the body, in the course of its voyage around the sun, was exposed to the incessant disturbing action produced by the attraction of the several planets. The comet, therefore, does not describe a simple ellipse as it would do if the attraction of the sun were the only force by which its movement were controlled. Each of the planets solicits the comet to depart from its track, and though the amount of these attractions may be insignificant in comparison with the supreme controlling force of the sun, yet the departure from the ellipse is quite sufficient to produce appreciable irregularities in the comet's movement. At the time when Halley lived, no means existed of calculating with precision the effect of the disturbance a comet might experience from the action of the different planets. Halley exhibited his usual astronomical sagacity in deciding that Jupiter would retard the return of the comet to some extent. Had it not been for this disturbance, the comet would apparently have been due in 1757 or early 1758. But the attraction of the great planet would cause delay, so that Halley assigned, for the date of its reappearance, either the end of 1758 or the beginning of 1759. Halley knew that he could not himself live to witness the fulfilment of his prediction, but he says, "If I should return, according to our predictions, about the year 1758, impartial posterity will not refuse to acknowledge that this was first discovered by an Englishman." This was, indeed, a remarkable prediction of an event to occur 53 years after it had been uttered. The way in which it was fulfilled forms one of the most striking episodes in the history of astronomy. The comet was first seen on Christmas Day, 1758, and passed through its nearest point to the sun on March 13th, 1759. Halley had then been lying in his grave for 17 years, yet the verification of his prophecy reflects a glory on his name which will cause it to live for ever in the annals of astronomy. The comet paid a subsequent visit in 1835, and its next appearance is due about 1910. Halley next entered upon a labour which, if less striking to the imagination than his discoveries with regard to comets, is still of inestimable value in astronomy. He undertook a series of investigations with the object of improving our knowledge of the movements of the planets. This task was practically finished in 1719, though the results of it were not published until after his death in 1749. In the course of it he was led to investigate closely the motion of Venus, and thus he came to recognize for the first time the peculiar importance which attaches to the phenomenon of the transit of this planet across the sun. Halley saw that the transit, which was to take place in the year 1761, would afford a favourable opportunity for determining the distance of the sun, and thus learning the scale of the solar system. He predicted the circumstances of the phenomenon with an astonishing degree of accuracy, considering his means of information, and it is unquestionably to the exertions of Halley in urging the importance of the matter upon astronomers that we owe the unexampled degree of interest taken in the event, and the energy which scientific men exhibited in observing it. The illustrious astronomer had no hope of being himself a witness of the event, for it could not happen till many years after his death. This did not, however, diminish his anxiety to impress upon those who would then be alive the importance of the occurrence, nor did it lead him to neglect anything which might contribute to the success of the observations. As we now know, Halley rather overestimated the value of the transit of Venus as a means of determining the solar distance. The fact is that the circumstances are such that the observation of the time of contact between the edge of the planet and the edge of the sun cannot be made with the accuracy which he had expected. In 1691 Halley became a candidate for the Savilian Professorship of Astronomy at Oxford. He was not, however, successful, for his candidature was opposed by Flamsteed, the Astronomer Royal of the time, and another was appointed. He received some consolation for this particular disappointment by the fact that, in 1696, owing to Newton's friendly influence, he was appointed Deputy Controller of the Mint at Chester, an office which he did not retain for long, as it was abolished 2 years later. At last, in 1703, he received what he had before vainly sought, and he was appointed to the Savilian chair. His observations of the eclipse of the sun, which occurred in 1715, added greatly to Halley's reputation. This phenomenon excited special attention, inasmuch as it was the first total eclipse of the sun which had been visible in London since the year 1140. Halley undertook the necessary calculations, and predicted the various circumstances with a far higher degree of precision than the official announcement. He himself observed the phenomenon from the Royal Society's rooms, and he minutely describes the outer atmosphere of the sun, now known as the corona, without, however, offering an opinion as to whether it was a solar or a lunar appendage. At last Halley was called to the dignified office which he of all men was most competent to fill. On February 9th, 1720, he was appointed Astronomer Royal in succession to Flamsteed. He found things at the Royal Observatory in a most unsatisfactory state. Indeed, there were no instruments, nor anything else that was movable, for such things, being the property of Flamsteed, had been removed by his widow; and though Halley attempted to purchase from that lady some of the instruments which his predecessor had employed, the unhappy personal differences which had existed between him and Flamsteed, and which, as we have already seen, prevented his election as the Savilian Professor of Astronomy, proved a bar to the negotiation. Greenwich Observatory wore a very different appearance in those days from that which the modern visitor, who is fortunate enough to gain admission, may now behold. Not only did Halley find it bereft of instruments, we learn besides that he had no assistants, and was obliged to transact the whole business of the establishment single handed. In 1721, however, he obtained a grant of £500 from the Board of Ordnance, and accordingly a transit instrument was erected in the same year. Some time afterwards he procured an 8-foot quadrant, and with these instruments, at the age of 64, he commenced a series of observations on the moon. He intended, if his life was spared, to continue his observations for a period of 18 years, this being, as astronomers know, a very important cycle in connection with lunar movements. The special object of this vast undertaking was to improve the theory of the moon's motion, so that it might serve more accurately to determine longitude at sea. This self-imposed task Halley lived to carry to a successful termination, and the tables deduced from his observations and published after his death were adopted almost universally by astronomers, those of the French nation being the only exception. Throughout his life Halley had been singularly free from illness of every kind, but in 1737 he had a stroke of paralysis. Notwithstanding this, however, he worked diligently at his telescope till 1739, after which his health began rapidly to give way. He died on January 14, 1742, in the 86th year of his age, retaining his mental faculties to the end. He was buried in the cemetery of the church of Lee in Kent, in the same grave as his wife, who had died 5 years previously. We are informed by Admiral Smith that Pond, a later Astronomer Royal, was afterwards laid in the same tomb. Halley's disposition seems to have been generous and candid, and wholly free from anything like jealousy or rancour. In person he was rather above the middle height, and slight in build. His complexion was fair, and he is said to have always spoken, as well as acted, with uncommon sprightliness. In the elegy pronounced upon him at the Paris Académie des Sciences, of which Halley had been made a member in 1719, it was said, "He possessed all the qualifications which were necessary to please princes who were desirous of instruction, with a great extent of knowledge, and a constant presence of mind. His answers were ready, and at the same time pertinent, judicious, polite, and sincere." Thus we find that Peter the Great was one of his most ardent admirers. He consulted the astronomer on matters connected with shipbuilding, and invited him to his own table. But Halley possessed nobler qualifications than the capacity of pleasing princes. He was able to excite and to retain the love and admiration of his equals. This was due to the warmth of his attachments, the unselfishness of his devotion to his friends, and to a vein of gaiety and good humour which pervaded all his conversation. Chapter 9.